All right, class, this is week 8. This week we're going to be working on exponential growth and decay, word problems, and graphing exponential functions. Today, we're just going to do word problems. Towards the end of the week, we'll be graphing functions. I kind of did it backwards. I should have did graphing first, but honestly, I forgot. Okay, so it's not a big deal because graphing is much easier than these word problems. All right, so let's get it. Okay, remember in our notes we wrote what function or when to use what formula. We wrote that in our notebook. So this is class 5. So I'm going to pull out the notes for this class because you need those so that you can remind yourself of when to use what form, okay? Or formula. All right, so when this right here, standard form for exponential functions, you use this when you are given a starting amount and the common ratio. Remember, the common ratio is the number that's being multiplied to get the next number in that function. You use exponential growth formula, which is this formula right here, when they give you the percent increase and the starting amount. You use exponential decay formula when you are given the percent of decrease, the percent amount that it decreases, and the starting amount. Okay, so these are the different formulas that you're going to use and when you actually use them. So please make sure you have this out handy as you're answering your word problems until you just know it by heart when to use what. Okay? All right, so let's look at the first one. It says the world population in 2000 was approximately 6.8 billion, okay, or 6.08 billion. The annual rate of increase, there we got that word increase, was about 1.26% or 1 and 2600%. So we are given a starting amount and a percent. So when you are given, and this the percent increase. So when you're given a starting amount, the amount that you start with in the year 2000, and the percent increase every single year is going to increase by this amount. Which one of those formulas are you going to use? Which formula are you going to use to write the equation? Which one did it say? Y is equal to, somebody said, C, parentheses 1 plus R to the X or T power. Okay? That is what you're going to use. All right? The first question, and we can go ahead and write the equation first. Our starting amount, everything is written in terms of billion. So our starting amount is 6.08 billion times 1 plus, and let's write this as a decimal. Remember, your R is written as a decimal. How do you write 1.26? Well, no, how do you write? This is a percent. What do you do to the decimal to write it as what do you do to this decimal right here to change it from a percent to a decimal? Very good. Move to the left 2 times. 1, 2. Okay, so this is where you're going to move that decimal. So now it's going to be 0.0126. So this is 0.0126 to the x power. This is the equation here. Okay? All right, so it says find the growth factor. Okay, find the growth factor of for the world population. So our growth factor is going to be B, this right here. So when we add this together, what does that give me? That's my B. That gives me 1.01 to 6. This is my growth factor. This is my B. This is what B is equal to, or my growth factor. My percent they gave me, this is the percent or the rate that's increased. But this is my growth factor. This is what is being multiplied to get to the next number, which is this number that's in the parentheses. Any questions about how I got this? This is my B. Okay. All right, so let's look at letter B. The next question. Suppose the rate of increase continues. So this rate of increase continues. Write the function. We already wrote the function or the equation. Function equation is the same thing. And that is this right here. Y is equal to the starting amount times, and I'm going to go ahead and add this together, which is my B. Okay. To the x or t power, because x in these functions represents time. That's years, days, months, minutes, hours. It's some unit of time. Okay, I'm gonna pause for the calls. All right, so let's look at question C. It says let x be the number of years. Okay, so x is going to represent the number of years, number sign of years. Okay. Pass after 2000, because 2000 is the starting year. We said that in the beginning. Find the world population at 2010. So that means if our starting year is 2000, let's write this out. So 2000 is the 0 year. So that means 2001 is the first year. 2002 is the second year. 2003, do you see the pattern? It's the third year. Then what would 2010 be? What year would that be? 10. The 10th year. So x is equal to 10. Is there anyone that's lost about how I get x to equal to 10? Okay. So now, in order to find what the population would be in the year 2010, we're going to substitute 10 in the place of x into our equation, okay? So this is y is equal to 6.08 times 1.0126 to the 10th power, okay? All right, so let's type this in our calculator. And remember, to clear your calculator, you press second plus 712. Second plus 712. So now I'm going to type this in. I have 6.08 times 1.0126. And then I use the caret key here. It's called a caret key. Don't ask me why. But that's our exponent key. And they call it a caret key to the 10th power. Okay? And when we do that, we press enter. And this is what we get. This is how many million people it's going to be. All right, so this is going to be 6.89 million. Okay, because it's billion, sorry. It's written in terms of billion, not million. Billion. Okay. That's how many billion it's going to be in 10 years. Any questions about how we got that? I'll pause for the calls. All right, so now we're going to do number 2. Number 2 says, a computer valued at 6,500. Okay, it depreciates. Anytime you buy items, they depreciate in value. Nobody wants something that you've used, really. You know what I mean? It's a used item. It's going to go down in value. So this is depreciate. This is decreases in value. So how much does it decrease by? Look, it gives you a percent. It gives you a percent of decrease right here, 14.3% every year or per year. So we're going to write the function. We're going to write the equation. What formula do we use to write this equation? Very good. To the x or to the t power. Good job. This is the form that we use. Y is equal to C, parentheses 1 minus r to the x power. This is exponential decay. So you're going to use the exponential decay formula. Okay. So now, using this form, let's go ahead and write the equation. What are we going to put in the place of C? Somebody at home, what are we going to put in the place of C? What's our starting amount here? Or starting value, rather. Anybody? Very good. 6,500. Okay. 6,500 is the starting value of the computer. Okay, so we have parentheses or times 1 minus r. We have to write our r or our rate as a decimal. So we're going to take 14.3%. It'll be what now? Very good. We're going to move it 2 times to the left. So just like she said, it's going to be 0.143 or 143. This is the thousandths place, THS, okay? To the x power. All right. Let's go ahead and subtract to see what this is, what this amount is. So we have here 1 minus 0.143. And that's going to give us 0.857. So this is y is equal to 6,500 or 6,500 times 0.857 to the x or t power. This is the equation here. Okay. And I'll pause for the calls. Are there any questions? Okay, so let's look at the next question. It says, find the value of the computer after 3 years. Can somebody tell me how we're going to do that? Does anybody know how we're going to do that? How we're going to find the value after 3 years? Yes. Very good. Here, x is equal to 3. So you're going to replace x with 3 and then just solve it, okay? So we got y is equal to 6,500 times 0.85, well, 857. And we're going to raise it to the third power because the number of years is 3 years. So let's type this in the calculator to see what the value of the computer is going to be after 3 years. Okay? So we got 6,500 times 0.857. And we got caret key here, 3. So we type that in. See how I typed it in? I use parentheses as multiplication. Okay? Press enter. And this gives me $4,091. And if we round it to the nearest cent, because this is money, this is going to be 25 cents. Because it's an 8 right here. Okay? So the amount again is going to be $4,091.25. Okay? Any questions about how we got that as an answer? Okay, and I'll pause for the calls. Are we okay? Are there any questions? Hey, Ella, how are you, babe? Good. Say again, babe. Say again, babe. The caret key is this key right here, babe. It's right over the clear. Ella, did you have a good weekend? Yes, thank you. Do you have any questions for me? Okay, all right. Did you miss a lot? You didn't miss too much, did you? Okay, okay, cool beans. Okay, so let's look at number 3. It says the population of a certain animal species decreases, y'all, okay? It decreases at a rate, given a rate or a percentage. So decreases at this percent, 3.5% per year. Okay. You have counted 80 animals, or 80 of the animals in the habitat that you are studying. Okay, so let's write the function. Which one of those formulas are we going to use to write the function or equation? Which one are we going to use? Let's do somebody at home. Let's do somebody at home. Okay? Which one of those formulas are we going to use? With the information that they give us, which formula are we going to use? So, you're right. It's y is equal to C1 minus R because it's decreasing. They give you the percent decrease. So you're going to use the exponential decay formula, okay? Very good. Excellent job. All right. So let's write this down. So what's our C going to be? Somebody from home. What's going to be go ahead. Very good, babe. 80. Okay. Excellent job. And we write parentheses 1 minus. Now we have to write 1. I'm sorry. We have to write our rate, a percent, as a decimal. This is written as a percent. Somebody at home. What is 3.5% as a decimal? Very good. You move it 2 times to the left. So you're exactly right. It's 0.035. Excellent job. And we raise this to the x power. Let's go ahead and figure out what b is. Let's subtract this, okay? So we got, very good, 1 minus 0.035. Okay, and look at this. We get 0.965. So we got y is equal to 80, parentheses 0.965 to the x or t power. Okay? Say again, baby. How'd I get mine? Did I type it in wrong? Let's go. 1 minus 0.035. See it? What'd you type in? Oh, I hit 0.1 or something. Oh, you're fine. It's all right. Because sometimes I'll be making crazy mistakes too. So it's always good to double check. All right. Are there any questions? Are y'all okay? All right. So here now it says graph. We're not going to graph this. Okay. And it wants us to estimate the number of years until the population first drops below 15. We're going to use the table to figure that out. Okay. We're not going to graph it. We're going to use the table to figure that out. So we're going to see when does it first drop below 15 animals. Okay. So this is how this goes. You're going to go to y equals to type in the equation, and it's 80 parentheses 0.965, close the parentheses, caret key to the x power. Please make sure that you type the equation in correctly, because of course if you don't, you're not going to get the right answer, okay? Any questions about how to type in that equation? All right. Now you're going to view the table values. So you see how table is in yellow? So anything that's in yellow, to access it, you have to press the second button first. So you press second and graph to get your table. So now you're going to figure out, okay, how many years does it take to get below when it first gets below 15 animals? Okay, so let's look at this side. It keeps going down. So we're going to look at the y values to see when does it go down. When does it first get below 15? We're going to keep going. I keep pressing the down arrow, just taking a look at the y values to see when does it get down to below 15. All right, so here, look, about 47 years before it gets below 15. About 47 years. Any questions about how I get about 47 years? Okay, so that's what I'm going to write here, about 47 years, because X is equal to the years, okay? Any questions about how I use the table to get 47? Okay. I'll pause for the calls. Are there any questions in general about anything? Is there anyone that is lost? Okay. All right. So the only thing that I want you to do is I want you to do one on your own, just so that I can see if you really understand what's going on. Okay. So I want you to do number 4 on your own. Okay. 4, A and B. And I'll go over 4A and B tomorrow. Are there any questions about what I'm asking you to do? All right, please use this time to go ahead and do this so you don't have to worry about it later. Okay, just go ahead and do it now. If you have questions, please feel free to ask. But at this time, I'm going to go ahead and stop the video. Are there any last minute questions before I stop the video?